guess I should.
Okay, so let's get the half angle identities quick. So the spot you go for the half angle identities
Is your YouTube channel.
is the YouTube channel, or you go to you start thinking about cosine of 2 theta, right? Why? I don't know, because this will be useful in calculus class. Trust me. Okay, so if you're thinking about cosine of 2 theta, you might think about that as that's cosine of theta plus theta, right?
Now it's fixed. You don't even have to go any further.
Okay, and now you could
Right.
plug this into the formula for sum of angles, right?
Right, let's do it.
Okay, so if you plug this in the formula for sum of angles, the cosine formula for sum of angles,
So it's cosine theta multiplied by cosine theta.
so you got cosine theta, minus
Sine theta multiplied by sine theta.
sine theta,
Yeah.
okay, which you could rewrite as cosine squared theta minus sine squared theta.
Which is 1.
Ah,
No, it's plus. It's plus.
Yeah, it's
No.
super not 1.
No. Forgive me. Forgive my sin.
Sorry, Zach. So how do I know it's not 1?
Because it's cosine squared.
Because if it was 1, cosine would be a really boring function. Right? Because cosine of twice anything would be 0. Or, sorry, would be 1. I'm pretty sure that that means that cosine of anything would be 1.
That'd be pretty cool.
Which would just make cosine a really, really boring function.
Well, I'm down for boring functions.
Okay, so if there was a plus sign here, you would be right. This would be 1. Since there's not a plus sign here, what you can do is you can make this into cosine squared of theta minus, and then what's sine squared?
1 minus cosine squared theta.
1 minus cosine squared of theta, which is, let's see, cosine squared minus 1
Plus cosine squared theta.
plus cosine squared theta. Nice. Okay, and then what are your like terms here? You got any?
Cosine squared theta.
Okay, there's 2 cosine squared thetas, right?
Yeah.
So all told here, I think I ended up with
Cosine squared 2 theta minus 1.
2 cosine squared theta minus 1. And then the thing of interest to me here is this guy, this cosine squared of theta.
Right.
So I'm going to solve that for cosine squared of theta. So I have here cosine of 2 theta is 2 cosine squared theta minus 1, right? And I'm telling you guys that instead of having this thing, which is called the double angle formula, I want the half angle formula, so I want this thing by itself.
Okay.
And I'm telling you this because, actually I'm not motivating this at all.
Okay.
There's a good reason for this.
Okay.
You don't have it yet. Sorry.
Okay. There is a good reason.
There is an extremely good reason.
Good. Bad.
This is, I feel like, there are 2 trig identities you should know. 2, count them 2. One is the sum of angles. No, scratch that. One is sine squared plus cosine squared is 1. And the other one is this.
Okay.
So, to get cosine squared by itself, what do you need to do to this thing?
Add it and then add it by 1 and divide by 2.
Add 1 and then divide by 2?
Yeah.
So, algebra will get you to cosine squared of theta is cosine 2, let me write this the right way, is 1 plus cosine of 2 theta over 2.
Just divide.
You guys cool with that?
Yeah.
Okay. If instead I had chosen to rewrite things in terms of sine, like back here, right? I'm going to get rid of the sines, right? If I had instead chosen to get rid of the cosines, I would end up with a similar formula for sine squared. And the formula for sine squared of theta is 1 minus cosine of 2 theta over 2.
And that's because it's
That's because of algebra. Put these in your brain. These are the half-angle identities. Cool. So if you want to do something like rewrite some cosines times some sines. Levi, what was the problem you were originally asking about?
Oh, so yeah, so sine squared theta multiplied by cosine squared theta. And write that in terms of constants and cosine of 2 theta.
So rewrite cosine squared theta times sine squared theta?
Yeah, in terms of cosine squared theta. In terms of cosine of 2
And
theta.
cosine of 2 thetas and constants?
Yeah.
There's a good calculus reason why you might need to do this. So what you do is you say, okay, cosine squared of theta is,
1 plus cosine 2 theta over 2.
so this whole thing is 1 plus cosine of 2 theta all over 2. That's the cosine squared part. And then the sine squared part is 1 minus cosine of 2 theta over 2.
Distribute the heck.
Yeah, so if you distribute the heck out of this, you'll find out that you get an over 4 on the bottom.
And then don't you have to foil the
There
top?
you go.
And then if you FOIL the top,
1 plus cosine 2 theta minus cosine 2 theta minus cosine squared 2 theta. Yeah.
and then the O and the I cancel, right? Because this thing looks like difference of squares.
Yeah.
You guys all see that? So you get to this guy.
Oh.
And then if you still wanted to get rid of the cosine squared, right, you could do this thing again. And you'd end up with, you'd have 1 minus something over 4. And your something here would be
Cosine 2 of 2 theta. Wow, so it'd be that.
1 plus cosine of 4 theta.
Wow.
You see that? Like, the thing in the square gets doubled when it's not in the square, right?
Yeah.
And then this is over 2. And then you could like fiddle around with that. And I know this looks like a wild trick, right? But
It's getting smaller and smaller.
this thing here, let me give you motivation. If you put some calculus symbols around this, this is an impossible problem. And this one is actually really easy.
Cool.
Cool?
Yeah.
So this is a trick by which you can turn what ought to by all rights be like crazy impossible into like, dude, I learned that like the second day of Calc 2. Right? Chill, easy peasy. I know it looks messy, but this symbol acts really nice with constants. So you just basically shovel all the constants out of there and life is pretty easy.
That's cool.
Cool?
Well, thanks.
I know I'm not motivating what this symbol is or does, but
But
It's
you're giving life to the thing we just did.
yeah, so what this symbol does is it calculates the area under curves, kind of. Or it's used for calculating the area under curves. So if I wanted to find out the area underneath this curve, I would fiddle around with it until I got to here, and then this is an easy problem to solve.
An integral.
Yeah, that's an integral.